Okay, so very first thing we're going to do, we're going to back up for just a second and go back into the chapter 1 graphs we're doing. So let's pretend like you had to graph just one of the regular functions that we had. Now, instead of the only difference between an equation and a function is equations, it's y equals, functions, it's f of x equals. So let's say it's x minus 3 squared plus 1. Okay, now here's one thing that we didn't really talk about before as we were going through these, and this is where we'll tie it in. That the last part, back in chapter 1 where we're doing this one, we said all we had to do was just find the 0, 0 spot where we're going to move it. Basically, we were talking about the vertex. I think we didn't actually talk about the vertex there. So this one, you're going to change this from -3 to +3, and this sign stays like it is. So this means that now our vertex was at 3, 1. Okay, so to graph this one, that's the key point that you've got to have to graph this thing. So we're going to go over 3, up 1, put a point right here, and then from there, the graphing, and again, I think with the online homework, you had to put in one more point to figure out exactly where it was going to be, but test-wise, we were basically graphing this thing to know that it would look like this. Again, we could go back and plug in one more point to get an exact value for the next one. So if we want to pick and the easiest way to do that if you're going through these is, again, to plug in the next point. If this one's x equals 3, pick a point that's right beside it. So let's plug in x equals 4. So whatever your vertex is, pick one more point, which is the next number right beside it. Pick the next whole number beside it. Occasionally they'll give you a decimal. But I'd say pick the next whole number beside it, plug it back in so you can find out what the next order pair is if you're going to graph this thing. Plugging in 4, it's 4 minus 3 squared plus 1. So that's 1 squared plus 1, which is 1 plus 1, so that would be 2. So the next order pair would be at 4, 2. With that next point right there. And that way, I think that's more of how the online homework was having you do, that once you drop the vertex and you clicked on this basic shape, you had to have one more point to figure out exactly where that next point was going to be. And you had to pretty much just kind of plug one in to get that next point that was here. Now, we didn't have to worry about that on the test because we just had to draw a basic shape of it. As long as you had this vertex value, that was the main thing we were looking for. Okay, so that's where, and that's when we're graphing these, they actually call that vertex form. What they're going to have you do is they're going to say, all right, well, what we're going to do in chapter 2, here in section 2, is that instead of having everything where we can just look at this problem and go, here's the x value, here's the y value, we're going to plot that point for the vertex, they're going to give you an equation where it's not in the vertex form. They're going to give you one where it's just in standard form, and you've got to go back and figure out what all those parts and pieces are. Yes, sir. Mm-hmm. Yes. Mm-hmm. That's parentheses, absolute value, square root. Anything that it's inside of when you're and that's going to be true what we're doing in chapter 2. That'll be true when we do it in chapter 3. If you're inside the fill in the blank, that point will always go in the opposite direction horizontal every time. And then the number that's on the outside of absolute value, parentheses, radical, whatever it is, that's always going to be an up and down motion, and it'll be in the regular position every time. So, okay. Okay, so that's what they would call vertex form, because you can look at it and pull the numbers straight out and tell me what the vertex is. If it's standard form, that's more of what we were doing back in section 1. when we were doing the quadratic formula. That's when you got ax squared plus bx plus c. Okay, now the good news is you don't have to use the quadratic formula on this one because, you can do that, but it's not really going to, it'll help you a little bit, but it's nothing you really have to do. Here's the big thing you need from this one. You need the vertex. Because that vertex is the most important point that you have that's on that graph. So here's the whole big thing you have to do. You have to get the vertex. To get the x value of the vertex, it's one simple little thing. It's negative b over 2a. So whenever you have this equation, to get the x value of the vertex, it's really simple. It's just negative b over 2a. To get the y value of the vertex, to get the y value, you have to plug the x value of negative b over 2a. Let's say it this way. We're going to plug in x equals negative b over 2a. Well, say it correctly there. We're going to plug x equals negative b over 2a into f of x. You're basically going to evaluate whatever that number is. You're going to plug it into the function, and when you get that answer out, that's going to be the y value. To show that, they're going to say, because it's a function, the notation for that is f of negative b over 2a. And when you're going through the online homework or going through the textbook, the vertex notation that they're going to show you for this thing is they'll put negative b over 2a, which is the x value, and then for the y value they're going to do f of negative b over 2a. It's not the best looking thing in the world, but that's the notation that they're going to use when they go through and talk about function notation with the vertex that's in there. Now, the one good thing, here's the one easy thing that you get from the negative b over 2a. The c value, that is your y-intercept. So the negative b over 2a kind of gives you the vertex, and you got to work through it a little bit. But the c value, really straightforward. Whatever the c value is, it's going to cross the y-axis at that point. If it's positive 2, it's up 2 spaces. If it's negative 4, it's down 4 spaces. That part's going to be easy. The other thing you're going to have is the a value. And the a value tells you the shape of the graph. And if a is positive, the graph looks something like that, where the arrows are going to be pointing up. The technical term is it opens upward. If the a value is negative, and the graph opens down. So it looks something like that. So the a value is it's kind of like the slope. Not that this is really like slope, but this would basically just kind of give you the general direction. If a is positive, then both ends of the graph are going to be pointed up or opens upward. If the a value is negative, then the graph has to go downward as you're going from that point. Now, they tie in a couple of things with this one. If you talk about the vertex, which is going to be right there, for this particular graph where a is positive, vertex is at the bottom, right? So in that case, they're going to say that the vertex, since that's at the bottom, is a minimum value. And on the part where the a value is negative, your vertex is at the top. And if it's at the top, then that's as high as you can get. The vertex is a maximum value. So that's some of the little things that they'll do. And again, some of that you can do just by looking at the A value and the C value. The B value, that's more of kind of finding the actual parts of the vertex. But some things they're going to ask you to do is they're going to ask you, okay, tell me if the vertex is a maximum or a minimum, what the y-intercept is, and then tell me what the vertex is. And then they'll kind of go through that one. So some of those things you can get, like the max or min, if you just know what the A value is, you just look at it. You know, if I know if it's negative, it's going this way, that's at the top of the mountain, so that's a vertex. You know, if this A value is positive, it's like this, the vertex is at the bottom, that means it's going to be a minimum value. And then, again, your C value, that's going to be your y-intercept. Okay, so here's what they're going to ask you to do. One other thing. Okay, when you draw the axis of symmetry, that's the line that's going to cut the graph into two equal halves. So the axis of symmetry is always going to be x equals negative b over 2a. And it's always going to be drawn through the vertex. So if we had if we were looking at this graph, you would draw a line. Most of the time they're going to make it a dashed line. So it would look something like that. But you've got a line going right down the middle. Same thing here. You'd have a line going right through the middle, equidistant on both sides. Because the vertex is always the middle of the graph, in the axis of symmetry. If you draw a line through it, it makes everything equidistant as you're coming out from there. Okay, so here's what they're going to ask you to do. They're going to ask you to, basically, they're going to say, all right, here's some equations, and just start graphing these things. And they're going to ask you to sketch the graph, of course. They're going to ask you to find the vertex, the axis of symmetry, I think even sometimes from these they'll ask for the x and the y-intercept, and we'll talk about that one too. Let's see if there's anything else. Oh, and domain and range. Yeah, this one is one of those kind of a 7-step questions where they, you've got, it's one problem, but then you've got 6 or 7 bullets you've got to go back through and answer on all these. Okay, and really there's 2 situations, and we'll kind of get both of these here. One is where they'll actually give you a graph that looks just like what we did back in the last chapter. Now, when we're doing this back in chapter 1, we didn't ask for all this other stuff back here. So this is where we're going to have to, the graph is going to be the easy part because it's going to be there and we've got it. It's getting all this other stuff they're going to ask for, the x-intercepts and the y-intercepts and all the other things that's on here. So let's get the first thing first. Okay, now here's one thing we didn't talk about back in the chapter 1, that when we're talking about the vertex form, when we graph one like this, the A value would always be right here. That what they're going to put a number in front, and that would basically be the A value. Everything we did, the A value was always 1 because it was kind of understood to be 1. If they want to make it change, we could look at one here in a minute where that would be -2, and that way this graph would go down, and that would be your A value. But for the problem we've got here, we'll just leave it so that A value is 1. Okay, so first things first. Let's get the vertex. Change the sign from -4 to +4. That number stays the same, so that is your vertex. Okay, the axis of symmetry, we'll just call it AOS for short, is always going to be whatever this x value is. So just tell me it's x equals 4. Okay, now here's the one part of this one that's not as good as it is before. To get the y-intercept, this is where you actually have to kind of do a little bit of work on this one. Because with the parentheses here, there's not just, now you have the -1 at the end, but this one you still haven't done the full method yet. So for the y-intercept on this one, you have to either rewrite this one where it's just one big thing in ax squared plus bx plus c form, or you have to plug in x equals 0, which I think was what we did back in chapter 1. So we'll plug in x equals 0. So 0 minus 4 squared minus 1. Well, 0 minus 4 is -4 squared. Minus 1, that is 16 minus 1, that would be 15. Okay, so the y-intercept, so this one's going to cross the y-axis at 15. To get the x-intercept, we'll do the opposite. That's where we're going to take and let y equal 0. Or, as it was before, it was the function that was, basically it's the f of x, because f of x and y are almost interchangeable here. Now, this one's a little bit more complicated, I guess you could say, to get the x-intercept on this one. Because for this one, if you're going to solve for x now, you've got to add this 1 to both sides. And you've got to get this from x squared down to x, so you've got to square root both sides. Okay, on the right-hand side, when you square the square root, those cancel, that leaves x minus 4. On the right-hand side, square root of 1 is 1. Now, the only catch is that when you square root 1, it could be positive or negative, because you could do -1 times -1. So this one, you have to make that either a plus or a minus 1. Which means, we'll bring this back up here, because right at the bottom of the page, you have two choices. Because you could have 1 or -1 equals x minus 4. Or positive 1 equals x minus 4. Okay, so this one actually has two x-intercepts. We're going to cross the x-axis at 3, and then we're also going to cross the x-axis at 5. So we have 3, 0, and we have 5, 0. Okay, now, in that one, here's where I'll be honest with you. What we're going to do throughout Chapter 2, you're not going to have to worry about this one so much, because it's going to be the other form that we're going to do more of. They'll throw you an occasional couple one of these, so we need to at least make sure you know how to work through these. Okay, so let's go back and get all the pieces here to put the graph together. Vertex is at 4, -1. For this one, the A value was 1, so we know it's going to open upward. And again, we'll just kind of put up here that the y-intercept was at 15. Okay, we had that the x-intercepts were at 3 and at 5. So that would kind of, and again, those would be equidistant parts. So if this is 1 over here, then this one's also 1 that way. The way I've got it drawn, this one actually will be kicked out a little bit more. Okay, and if you had to draw the axis of symmetry, it would be right down, well, right down the middle. Let's go just a little bit. There we go, pretty close. No, it turned okay. There we go. Oh, and then the last thing that we didn't get here, domain and range. Again, for functions, we said, and this is kind of where it ties back in, and this is back where we'll be back in chapter 1. If you, domain, you're looking left and right. This will keep going forever to the left. This one keeps going forever to the right. So domain would be -infinity to infinity. Your range, that's how far up and down you go. It definitely bottoms out right here at -1. So we're going to go from -1 at the bottom, and then it's going upwards to infinity. So it's -1 to infinity. Okay, so there's all the pieces that you've got to do. And depending on which form they give to you, there's parts of it that makes it easier. Going back just for a second, back to the other page. When you have it like this, the vertex is really easy. It's the other stuff that gets a little tougher. Finding the x-intercepts, finding the y-intercepts, it takes a little bit more work to get there. When we do the next one that we'll do, this is one where the vertex is the hard part, but everything else should come pretty easy just based on the way the numbers kind of roll out of this thing. Okay, same thing they're going to ask you for, all those 6 or 7 things that they're asking you to find. Just some of them you have with parentheses, some you don't. And it really comes down to which form you have. This one, this is your A value. So A value is 2. B value is 4. C value is -3. And the good thing about this one is that as soon as you get this one, this is your y-intercept. 0, -3. Okay, the A value, written this way, you know the basic shape of it because this A value is positive. You know the graph has to look something like that. And here's where the vertex is going to help us find everything else. For the vertex, the x value is -b over 2a. So we've got to plug those numbers in. Now, and again, here's one little thing I would say that might make things easier because, again, thinking about what I've seen people make mistakes on. When you do the vertex, when you plug these numbers in, it might help to put the b and the a values in parentheses. That way when the negatives, because the negatives will show up, they didn't on this problem. But when the negatives show up, that way everything's kind of spaced out and you can see exactly what's going on. So this one is the negative of 4 over 2 times 2. That's -4 over +4. So that's an x value for the vertex that's at -1. Okay, and again, we're not going to do f of x, just do y equals. Then we're going to take out the x's and plug in -1. Okay, so again, you have -1 squared, which is 1, so that's 2 times 1 plus 4 times negative, actually that's a minus there, because 4 times -1 is -4. Minus 3, so that's 2 minus 4 minus 3. -2 minus 3, so that would be -5. So we plugged in x equals -1 to get a y value of -5. To get your vertex. Vertex is -1, -5. Okay, and with that vertex, you get one other freebie from that one. That is your axis of symmetry is just this x value. So x is -1 for the axis of symmetry. Okay, so let's graph this thing. Okay, so -1, -5. -1, -5, that puts the vertex right there. Okay, the other thing we had was the y-intercept was -3. So that's right here. And again, the good thing with the axis of symmetry, once you've drawn it, I'll put it in green right here so it stands out a little bit better. When you draw the axis of symmetry, everything has to be equidistant. So for this point, the blue point, when we find the y-intercept, that was 1 point over this way. It's basically it's 1 off of the axis of symmetry to the right of it. You can put a same point 1 spot over to the left of it, because everything has to be symmetrical now. Okay, now, and for me, if we were doing this on a test, I would be good with that. You could come back in and draw the dots on this thing and get your graph, and then you're good to go. They ask for the x and y intercepts to get that one. Now, if you're drawing this one, you know, if you're doing on online homework, you can draw it in and it'll have it here. Come out to where it's exact whole numbers. I think this is one of those where it's actually going to be decimals. So if we go back up here, 2x squared plus 4x minus 3. To get the x-intercept, if you plug in 0 for y, it doesn't really, I mean, you could work it that way. But basically, you either have to factor it, go through and factor, see if it factors. If it does, you can solve the factor and you get the two numbers you need. If it doesn't factor, then you have to use quadratic formula. Okay. Now, and this is, if we're going to check the factoring on this one, this is where you have to do the AC method. So it's 2 times negative 3, which is negative 6. So are there any factors of negative 6 where the sum would come out to equal positive 4? And there's no way you can take 1 and 6 or 2 and 3 and ever get an answer of 4. Okay, so this one does not factor. So the bad news is now you have to do the quadratic formula to find out what those numbers are. Now, no, they don't. They're going to make you do the quadratic formula here. So we're going to run through the quadratic formula one time. And this is, again, going back to section 1. It's negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And again up here, a value was 2, b value was 4, and c value is negative 3. And again, if you can kind of get used to the habit on this one, when you plug in, especially the b value, put the b value in parentheses. Because when you do the 4 times the a times c, it automatically kind of works its way out. But the b values, if you put those in parentheses, that usually helps people get through the couple of mistakes that sometimes tend to pop up as you're going through this. Okay, so it's the negative of 4 plus or minus 4 squared minus 4 times a times c. And this is all over 2 times 2. Okay, so working it out, that's negative 4 plus or minus the square root of, this is 16, 4 times 2 is 8, 8 times 3 is 24. So it's negative 4 plus or minus the square root of 40 over 4, and this is one where you have to take the 40. And now, if you're finding just if you're finding the x-intercepts on this one, you really don't have to take the 40 and break it down. That's one where you can just go ahead and use your calculator and figure out that if we do the square root of 40, it should be 6.324555. Okay, now here's where, again, it's basically once you get to this point, it's a calculator problem. That you're still going to need 2 answers because of the plus or minus. So over here, you can do negative 4 plus that number divided by 4. And on one of the part, you need to do negative 4 minus that number. Okay, so if we will run this number through the calculator, first number comes out to be 0.581 if we go to 3 decimal places. And for this number, this comes out to be negative 2.581. I'm going to scroll back up real quick. So if we had, on the graph, if we had had this one, well, there we go. That point here is negative 2.5 because there's 1, there's 2, so it's somewhere between 2 and 3. This one at 0.5 means that would have been about here, where that's at almost 0.6 to kind of go for that part of it. Okay. Oh, one other thing we did not do. Come back up here real quick. Domain and range, real quick on that one. Domain for any quadratic is always negative infinity to infinity. That part never changes. The only thing that's going to change on this one is the range. This one we dropped it down to -5 because that was the x value of our vertex. Sorry, it's the y value of our vertex. So this one's going to start at -5 and then go to infinity. All right, now let me give you just a quick what if here. Now, if this graph had gone this way, the only thing that would have changed with that graph is that this, again, the main would still be the same. Your range, though, since you have a high point, that's going to be the second number. And that would have capped it off. This one would have run from -infinity up to -5. So just realize that if it's going down, your lowest number is -infinity. Whatever number you hit here, that's going to be your high number where you max out at that point.